Pagurus bonairensis, Schmidt, 1936, family Paguridae. This species was one of the most ecologically limited of all those collected in Curaçao. All specimens were collected inside Paguridae Bay on shallow mudflats. Moreover, with the exception of one individual, all were found in one small section of one of the innermost inlets of that bay. Pagurus bonairensis is a medium-small crab, averaging about 6 millimeters in cephalothorax length. Although Pagurus bonairensis may occur elsewhere in the Paguridae inner bay and in parts of other bays, I found it in a very limited area. There were two medium-sized populations, separated by about 5 meters, spread out along 20 to 25 meters of one side of one small indentation in the shore, not too far east from the landhouse Klein Paguridae. The waters this far into Paguridae Bay are rather cloudy most of the time, and it was rarely possible to see crabs in water deeper than 20 centimeters. The only unique feature of this particular inlet observed was the very gentle slope of the soft mud bottom, which was not left dry at low tide. There are no mangroves along this particular section, and the gentle slope of the bottom assures water coverage under normal circumstances. The majority of animals were found about 50 centimeters from shore, in water 3 centimeters deep. At low tide, there were decidedly fewer crabs visible, but the decreased visibility of the area makes any statement on tidal migration tenuous. It could not be judged whether the crabs simply moved up and down with the water level, thereby staying in about the same depth of water, or if there was a real migration to deeper water during low tide. At night, the problems of visibility were multiplied. During the day, especially during high tide, the crabs were rather active, moving about some and feeding. Mating pairs could frequently be seen, the male dragging the female about both during the day and at night. Around 1800 hours, the crabs start moving generally toward deeper water, apparently irrespective of tidal factors. By 1830 hours, there are markedly less crabs in the area. Very few individuals could be found at night. The population density appears to be at approximately diurnal level by 600 hours. The table below shows the results of the field distribution counts along portions of the shore at 2 different times. The crabs are contagiously distributed. Field distributions of Pagurus bonairensis. A table I am not reading. The table below shows the results of the measurement of laboratory distribution of Pagurus bonairensis. The laboratory populations were set up in medium-sized glass aquaria, externally marked every 6 centimeters. The distribution of individuals was random in the late afternoon and at night. The contagious distribution seen in the morning counts may be a result of grouping in corners of the aquarium, rather than true gregariousness. Laboratory distribution of Pagurus bonairensis. Another table I am not reading. Pagurus bonairensis is an active, fast-moving species. Although an individual may not move much while feeding in an area, its locomotion, when disturbed, is rapid. The ambulatory legs and chelipeds of this crab are relatively long and slender, and both in its speed and manner of movement, bonairensis is somewhat spider-like. The ambulatory raise is not as frequent in aggressive meetings as movements of the chelipeds. Ambulatory raises occurred 394 times in 1,060 interactions, while 567 cheliped extensions and 291 presentations took place. The ambulatory raise is a very rapid, continuous act. The limb is not often maintained in the raised position for any length of time. It is raised through about 40 degrees to a position slightly below the horizontal within 0.12 seconds. In the raised attitude, the dactyl is curved somewhat downward. After a short time in the fully raised position, the limb is usually brought down rapidly, 0.06 to 0.12 seconds. The movement involves a horizontal element of about 30 degrees. The limb is moved forward as it is raised and brought back as it is lowered. The cheliped presentation display is similar to that of other pagurid crabs. The cheliped extension is of two types. The standard forward movement with little horizontal motion is much more frequent. The major cheliped is carried doubled back under the mouth area, and thus the major dactyl may be moved through 130 degrees to a position about 15 degrees below the horizontal. The proximal segments are horizontal, or even a little higher in the raised attitude. The minor cheliped is straighter and more nearly horizontal when extended. The motion upward takes 0.36 to 0.48 seconds and may be brought back to the neutral or presentation position just as quickly. In addition to this aggressive movement, a second cheliped movement was observed a few times. This sequence of movements brings the major cheliped out and to the side at an angle of about 45 degrees to the anterior-posterior axis of the body. It is then moved up and back a bit further, the limb at that time being about 20 degrees below the horizontal and 55 degrees back from the AP axis. It is then brought diagonally down, forward and toward the body midline to a position about 30 to 35 degrees below the horizontal and 15 degrees away from the AP axis. It may then be brought back and the movement repeated, or returned to either a neutral or presentation position. When the animal was pulled back into its shell, the major dactyl of an individual frequently was flicked upward rapidly when disturbed by another crab. Pagurus bonairensis executes the dislodging shaking movements typical of pagurid crabs. The motions are somewhat more rapid and violent than those of P. miamensis. The twisting side-to-side action is very often successful in physically dislodging an offending conspecific individual. Shell-fighting behavior follows the patterns for pagurid crabs. Most of the wrapping motions are very short and rapid, about 4 cycles per second. Spasmodic shaking and wrapping occur about equally during the course of shell fights and are not too unlike in speed or distance of movement. Positioning behavior, a slow, quiet rocking of the defender by the aggressor about the axis perpendicular to and through the shell aperture of the defender, frequently occurred between series of wrapping motions and or spasmodic shaking. This rocking sometimes increased gradually in speed and changed very smoothly into spasmodic shaking. Sexual behavior followed the typical pattern for pagurids, although it occurred more frequently, 36 times in 1,060 interactions, than in other species. Even though the observable populations were never large, usually less than 100 individuals in the laboratory and less than 200 visible in the field, mating pairs were almost always observable. In the field, the sight of a male holding onto or dragging a female about with his major cheliped grasping one of her first ambulatories, while both carried out feeding motions, was rather common. Occasionally, a female was pulled about by a hold on the rim of the shell aperture, either upon first encountering and attaining an opposed position with a female, or after some minutes or hours of holding a female by the aperture rim, a male rocks the female back and forth, about 30 degrees movement, around the axis perpendicular to and through the plane of the female aperture. The male may also rotate the female back and forth about the axis, parallel to the substrate and perpendicular to his anterior-posterior axis. After some minutes of these rocking movements, the female comes up partially, and the male grasps one of her appendages with one of his chelipeds. The male then may pull the female about, hold her quietly in the opposed position, or hold her by an ambulatory leg while she is in an upright posture. This latter attitude usually continues for some minutes or is intermixed with short, jerking movements by the grasping cheliped of the male. These movements, which pull the female toward and away from the male, are similar to those described for Pagurus miamensis, although they are somewhat longer, 1 to 2 millimeters. After some minutes of this jerking behavior by the male, the female begins picking at the ambulatories and free cheliped of the male with her chelipeds. She continues to move her chelipeds, especially the minor, and sometimes her ambulatories over the appendages of the male and in his mouth-eye stalk region. The male eases out of his shell, exposing his cephalothorax and anterior portion of his abdomen, and bends the posterior part of his cephalothorax toward the aperture of the female. At this time his fourth and fifth periopods move back and forth between the male and female. However, unlike all the other species observed, the female often does not come partially out of her shell. Although the female and her behavior is obscured by the male, it appears that she remains in her shell and moves her minor cheliped back and forth rapidly between the genital opening of the male and herself. The male is extended in this copulatory position for 5 to 15 seconds. Following copulation, the male pulls back to a normal position, and the female ducks down into her shell as far as the male's grasps of her ambulatory allows. The male then either releases the female and moves away, or, more frequently, begins to perform jerking movements again. Post-copulatory behavior is an exact repetition of the later phases of pre-copulatory behavior. Indeed, it sometimes leads to a second or even third copulation between the same two crabs. I never observed more than 3 copulations by any one pair. In one case, a female mated with 3 different males in succession within 45 minutes. Each time, the male which had just copulated was chased away by an intruding male. In every mating observed, the female was still carrying well-developed embryos which were near the stage of a release, and the female exoskeleton was hard. Spermatophore filaments were almost always found around the bases of the first 3 pairs of female periopods. The males of mating pairs were 19 to 54% larger, cephalothorax length, than the female, average 34%. The results of the monthly collection and measurement of egg diameters is shown in Figure 24. From July 10 to 22, every female collected was carrying eggs externally. The variation pattern is inconclusive, and the idea of a lunar synchronization is neither negated nor supported. The diel variation in activity is shown in Figure 25. The locomotor activity figures were not averaged due to the differences between the 2 days of observation. Figure 24. Variation in average egg diameter in Pagurus bonairensis during May 1963. Figure 25. Diel variation in activities of Pagurus bonairensis. Feeding activity shows evening peak. Aggressive level shows morning peak. Locomotor pattern variable 2 days presented separately.